What if someone told you that the most iconic airliner ever built a plane that literally democratized air travel for hundreds of millions of people could be reborn with just 2 engines? That one day, an aircraft the size of the Boeing 747 could cross an ocean on a pair of engines so powerful, so efficient, that 4 would simply be unnecessary? It sounds like the kind of idea that belongs in a concept video, not a real boardroom. But the engineering pieces for exactly that scenario are slowly, quietly falling into place. The question is whether Boeing or anyone is actually building it. Let's start with history and the emotional part of this story, because you can't talk about a Boeing 747 replacement without understanding what the Boeing 747 actually meant. In December 2022, the last Boeing 747 rolled off the production line at Everett, Washington. A 54-year production run, over 1,500 aircraft built. The jet that made cheap international travel possible for everyday people. The Boeing 747 cut per-seat costs by up to 30% compared to the narrow bodies of its era, and that gap was enormous enough to reshape the entire global airline industry. The Boeing 747 didn't just carry passengers. It carried the idea that flying was for everyone. But even as the Boeing 747 was still being celebrated, the forces that would end its reign were already in motion. It started in 1974, when Airbus put the A300 into service, the world's first twin-engine wide body. At the time, nobody fully understood the implications. Regulators wouldn't even allow twin-engine jets to fly oceanic routes for years. But as engine technology improved and ETOPS rules were extended first to 120 minutes, then 180, then beyond the logic of 2 engines versus 4, began to tip in one direction, decisively. The turning point came when Boeing introduced the 777. Here was a twin-engine aircraft capable of doing everything a Boeing 747 could do on intercontinental routes, but burning far less fuel and requiring half the engines to maintain. Boeing read the market correctly. Airbus, meanwhile, went the other way and built the A380, a double-decker super jumbo that could carry more than 550 passengers. It was an extraordinary engineering achievement. It was also a commercial mistake. The A380 ended production in 2021 after just 251 aircraft, ending before the Boeing 747's last delivery. The market had voted, and it voted for twins. Today, the Boeing 777-9 is the world's largest twin-engine commercial aircraft. It carries around 426 passengers in a typical 2-class layout. Its engines, the GE9X made by GE Aerospace, have a fan diameter of 128 inches larger than the fuselage diameter of a Boeing 737. And the FAA issued a type certificate for the Boeing 777-9 in late March 2026, clearing the aircraft for commercial deliveries after a certification process that began in 2019 and became one of the longest and most scrutinized in US aviation history. Lufthansa is expected to be the first airline to receive the Boeing 777-9, with initial deliveries projected in 2027. It is arriving, finally, but years behind schedule and at enormous cost, roughly $15 billion in program overruns. Now here's where the story gets genuinely fascinating. The GE9X is, by any measure, a monster of engineering. But there's a company in Derby, England, that has been quietly building something even bigger. And that company is Rolls-Royce. Rolls-Royce intends to begin further ground runs of its original UltraFan demonstrator in 2026, building on initial test activity that concluded in 2023, during which the engine accumulated around 70 hours of runtime. The wide-body UltraFan, now formally designated the UltraFan 80, has a fan diameter of 140 inches. That is 12 inches larger than the GE9X. It produces around 85,000 pounds of thrust in demonstrator configuration and is designed to scale up to 100,000 pounds. For context, a Boeing 747's 4 engines together produce roughly 240,000 to 260,000 pounds of thrust. 2 engines at 100,000 pounds each gets you to 200,000. With airframe efficiency improvements and composite construction, that gap closes faster than you might think. The scalable UltraFan can produce from 25,000 to 100,000 pounds of thrust and features carbon titanium fan blades, ceramic matrix composite components, and a geared design that could deliver a 25% improvement in fuel efficiency compared to first-generation Trent engines. So the engine capable of powering a two-engine Boeing 747 class aircraft might actually be in test right now. Does that mean Boeing is building one? Absolutely not. Here's the reality check that matters most in 2026. Boeing is a company that is still in deep recovery mode. The Boeing 737 MAX crisis that began in 2018 and 2019 permanently changed how the FAA certifies Boeing aircraft. The 777X program consumed $15 billion in overruns and took 6 years longer than planned. Boeing's current CEO, Kelly Ortberg, has been explicit that his priority is executing on existing commitments, not launching bold new programs. The Boeing 787 production line is stable but fragile. The Boeing 737 MAX 10 still needs full certification. The deferred revenue associated with 777X orders represents one of Boeing's largest single financial exposures, and the company cannot absorb another troubled new program. Beyond Boeing's specific situation, there's the broader market question. Who actually needs an aircraft this size? The honest answer is very few airlines. And that's the fundamental commercial problem. The aviation industry has spent the last 2 decades moving away from the hub and spoke model toward point-to-point routes. The Boeing 787 Dreamliner made it economical to fly a route like London to Austin without connecting through a hub. Passengers prefer it. Airlines like the operational flexibility. A 500-seat twin-engine aircraft works brilliantly if you can fill 500 seats on the same route multiple times per day. Most airlines cannot do that. The A380 taught the industry that lesson at great expense. But there is one carrier that has always been the exception to this rule, and that carrier is Emirates. Emirates operates out of a single hub, Dubai International Airport. Between Dubai and London Heathrow, Emirates flies 4 to 6 A380s per day, depending on the time of year, and all are full in both directions. Emirates holds orders for 205 Boeing 777X aircraft and is the type's largest customer. But even the Boeing 777-9, which seats around 426 passengers, is smaller than the A380. If Emirates replaces its A380s with Boeing 777-9s on its densest routes, it needs more slots at Heathrow, at Paris, Charles de Gaulle, at Sydney, at JFK. And those slots are either extraordinarily expensive or simply unavailable. The Boeing 777X's capacity advantage at slot-constrained airports like London Heathrow or Dubai remains its most important selling point. But even that advantage is not quite large enough to replace the A380 on a one-for-one basis. This is the market case for a Boeing 747 class twin. Not the broad global market, but a narrow, high-value segment of slot-constrained, high-frequency, hub-dominated operations. It is a real need. It is just not a need shared by enough airlines to make a new aircraft program commercially viable without taking on enormous risk. In parallel with the wide-body UltraFan, Rolls-Royce has started work on a smaller variant known as the UltraFan 30, intended for narrow-body applications, with a planned ground run in 2028. Rolls-Royce CEO Tufan Ergin Bilgic has confirmed the company is seeking a development partner for the UltraFan 30 program, with both Airbus and Boeing described as keen for Rolls-Royce to participate in the narrow-body market. The engine maker is clearly positioning itself for the next generation of aircraft, both large and small. But positioning for a market and building for it are very different things. A perfect engine does not automatically create a viable aircraft. It creates a possibility. The aircraft still needs to be designed, certified, built, and sold to a sufficient number of airlines to break even, a number that likely runs into the hundreds of orders before a program turns profitable. For a Boeing 747 class twin, that customer base simply does not exist at the scale needed today. What might change that equation? Airport congestion, accelerating. According to analysts, Airbus, Boeing, and Embraer are collectively selling close to 2 years of production for every calendar year, with the largest aircraft families effectively sold out until around 2035. As the global fleet grows and slot availability at major hubs tightens further, the case for very large aircraft strengthens. If the number of airlines operating full-capacity hub models grows, whether in Asia, the Middle East, or even Europe, the commercial logic shifts. But in 2026, Boeing is not planning a two-engine Boeing 747. It is not even planning the conversation. What does exist is an engine program that could theoretically enable one, an airline in Dubai that would desperately want to buy one, and a gap in the market that grows more visible every year that Heathrow and Dubai refuse to add runways. That is not nothing. In aviation, it is exactly how the future starts.